moving into the third process that deals with the formation of urine and filtrates, we're looking at tubular secretion. Now, tubular secretion is taking components from the capillaries and putting them back into the filtrate. So this pretty much is thinking about reabsorption, but in reverse. Because reabsorption was pulling all those materials out of the filtrates and putting them back into the blood. This part, this tubular secretion, this is now taking them from those capillaries and getting them into the actual renal tubules. Things like potassium, hydrogen ions, NH4, creatine, organic acids. These are all being added into the filtrate from the blood. Now, one of the reasons this is occurring is maybe some of these things were in proximity or bound to plasma proteins. Because if it's with a plasma protein, those cannot filter through. And a lot of times they're just kept away, so this helps pull things back. It helps make sure we maintain the homeostatic balance of pH, hydrogen ions. Make sure balancing off the different ions, the different electrolytes, everything is being kept just how your body needs it. Now, why is it important to rid the body of excess potassium? Well, we know from previous chapters and from AP1, potassium plays a role in your electrolyte balance in your body. Plays a partial role in water balancing. Plays a role in the membrane charges from positive and negative. So we have all these different things, plus more that we haven't even talked about recently, are all part of potassium. So you want to make sure that you keep those in balance. Too much, and you throw the balance off. You throw homeostasis out the window. Blood pH. We know the body likes to keep blood pH in that 7.35 to 7.45 range. That's a pretty narrow window to maintain homeostasis. Well, by altering the amounts of hydrogen ions, you then can change and alter as well the amounts of bicarbonates, HCO3-. Together, those can alter the pH of the blood because both are utilized in the buffering mechanism. Remember, it was H2O plus CO2. Combine that makes H2CO3, carbonic acid. And then that H2CO3 can dissociate a hydrogen ion, and HCO3-, bicarbonates. And then that can recombine back to the H2CO3. The idea is you're going back and forth depending on how the blood is. Is it too acidic? Is it too basic? You keep buffering back and forth. So by having excretion of hydrogen ions, having excretion of HCO3-, bicarbonates, you're helping to buffer the blood. Now we've seen this diagram before. This image we saw back with the reabsorption we talked about. So all of these light purple ones, those are the reabsorption we've already discussed. We already covered that in a previous video. We need to focus on these light tan ones. That is the secretion, the tubular secretion. So this particular one right here, that's going into the proximal convoluted tubule. You're seeing things like NH4, hydrogen ions, urea, uric acid, certain different drugs, even creatinine. All that is going back into the filtrate, back into the proximal convoluted tubule. That means that's going back in and it's going to be filtered out of the body then. Because this filtrate is leaving via urine. Now, there's another one here. Urea. Urea is being brought back into the filtrate. Again, this is the tubular secretion. Back into the filtrate in the loop of Henle. It's going to help deal with the concentration of urine as well as balancing out the various ions. And the last one over here. Notice hydrogen ion, potassium ion, NH4 again. It's going back into the end of that distal convoluted tubule as well as the collecting duct. And it's again all about balancing out the different ions and the homeostasis control in the body. Try and make sure the blood pH is balanced. Make sure your ions are balanced. Make sure your electrolytes are balanced. You're trying to maintain homeostasis across all of your systems. So a little bit about your tubular secretion. Things are going back into the filtrate from the blood or the different cells.